Okay, so this is going to kind of piggyback off of what we did on Friday. A lot of it's going to be the same, so hopefully it's going to be easier this time around. Okay, so first we're going to do is we're going to graph our quadratic parent function, which is y equals x squared. We know our a value comes in front right here, so that's a 1. And when I know our a value is a 1, what we do is we go up 1 over 1, up 3 over 1. And remember, that's like our home base that we are going to compare everything to. And my vertex of the parent function will always be the origin. So let's go ahead and graph it. My origin is my vertex. And from that vertex, I'm going to go up 1 over 1. And then from there, I'm going to go up 3 over 1. Well, we know that a parabola has an axis of symmetry that goes through the vertex. So I'm going to mirror my points across my axis of symmetry to get my full parabola. And there it is. So that is our parent function. That is what we compare pretty much everything against, right? All of our other parabolas we're going to compare against the parent function. Okay, so we're going to compare on example 1 this new equation that it's giving to me in vertex form against this parent function. Okay, so first let's figure out what's going to happen. Well, the only change for my parent function is that I have a plus 2. I'm adding 2 to my x. Well, remember what I told you about your x's. They're liars, right? So I know x is going to either move it left or right. Well, naturally, I would think plus would mean to the right. That would make sense naturally. But since x's are liars, I know it's going to go backwards. That's to the left. So I know it's being moved left, 2. All right, my a value. The a value didn't change. I still have a 1 out front. So I know that's going to be exactly the same as the parent function. It's going to go up 1 over 1, up 3 over 1. My vertex. Okay, so remember, we get the x from our vertex by looking at our x. I know it's adding 2. So since x's are liars, since it's adding 2, I'm going to put a negative 2. My y comes from the very end of my equation. Well, there's nothing out there, so I know my y value is going to be a 0. Okay, so let's graph this vertex. Negative 2, 0 is here. I know I'm going to go up 1 over 1, and then from there up 3 over 1. So I have half of my parabola. My axis of symmetry is going to go through my vertex, so I'm going to mirror it across to get my full parabola. Okay, I'm going to zoom out, I guess, real quick. Okay, so at the very beginning, we said it was going to move left 2. And notice your picture. It looks like, here's my parent function. It looks like this guy just got slid over to the left 2 spaces. See? All right, so on this next one, I notice it's happening to x. The x-axis goes left and right, so I know it's either moving left or right. Okay, naturally I would think backwards for a minus, but since x is a liar, it's going to move to the right too. My a is the number out front. Well, my number out front is still a 1, which means I know it's going to move up 1 over 1, up 3 over 1. Okay, to find our vertex, we look by what's happening to the x. Well, it's subtracting 2. So x's are liars. So since it's subtracting 2, I'm going to put a positive 2. My y value is at the very end, and there is nothing back there, so my y value is a 0. Okay, so we're about to graph it. Know that it should shift to the right 2 of the parent function. Okay, so my vertex is 2, 0. From there, I'm going to go up 1 over 1, and then from there, up 3 over 1. I need to mirror it over my axis of symmetry to get the full parabola. Oops, that's kind of ugly. Okay, that's kind of ugly. I don't know what I did over here, but okay, so you should see, here's my parent function. This one said it should move to the left 2, which it did. this one was moved to the right 2 from this parent function. All right, cool. Let's keep it going. Example 2. All right, so I'm going to quickly sketch my parent function again just because we compare everything to it. So I know my vertex is at the origin. I know it goes up 1 over 1, up 3 over 1, and I mirror it across. All right, so that's the parent function. We compare everything to it. All right, so now we're going to look at some different changes. So these aren't going to be happening to the x. This is happening at the end. We know that affects our up and down, our y, right? The y-axis. So since it's a -2, I know it's going to go down 2. Our a value comes out front. Well, that's still a 1. So I know it's going to go up 1 over 1, up 3 over 1. Okay, to find my vertex, I look by the x. Notice there is nothing being added or subtracted to the x. Okay, remember, your a value and your x value are not the same, all right? So there's nothing being added to the x, there's nothing being subtracted to the x, so my x value is 0. Your y value you get from the very end, which is a -2. So my vertex is at 0, -2, so I go put my vertex. Oops, 1, 2, that's here. Almost put it too low. And I need to go up 1 over 1, and then from there, up 3 over 1. Mirror it across the axis of symmetry to get your new vertex. To get your full parabola. So we started at 0, -2, I went up 1 over 1, up 3 over 1, and then I mirrored them across. Okay, so we said it was going to move down 2, so if you compare, notice from here to here, it just pulled it down 2. Okay, on this one, it's happening to my y, right? So it's a plus, so I know it's going to go up 2. My a value, look in front, is still 1, so I know it's going to be up 1 over 1, up 3 over 1. To find my vertex, to get the x, I look at the x. There is nothing being added, there is nothing being subtracted, so my x is 0. My y value comes at the very end, that's a +2. So my vertex is at 0, 2. We said to go up 1 over 1, then up 3 over 1. Here's my axis of symmetry, so I mirror it across. Notice it got shifted up 2. Excuse me. All right. So we showed moving it left and right. We showed moving it up and down. All right, so let's look at something else that's going to change this time. I'm going to quickly sketch my parent function. Should be getting pretty good at that by now. I know my origin is at 0, 0. It goes up 1 over 1, up 3 over 1. And that is the parent function, which we're going to compare everything to. Okay, so let's look at what changed from the parent function. Well, now I have this 2 out front, so my a is 2. Okay, well, the other day we learned that the bigger your a value is, if it's greater than 1, it's going to make it narrower, skinnier, more narrow. Not sure. Okay, anyway, so usually the parent function, I'm going to write it right here so we can see it, is up 1 over 1, up 3 over 1. And that is when a is 1. Okay? All right, well, a is 2 now. All right, well, I know it's still going to be going up because that's positive. And I know the over 1 never changes. What does change is this 1 and this 3. So since my a is now a 2, I'm going to take these first numbers and multiply it by 2. 1 times 2 is 2. 3 times 2 is 6. So one more time. I know it's still going up because this is a positive value. But now, because a is 2 instead of 1, I need to double these values. I doubled these, 2 and 6. Okay, so my vertex, we look at the x. There is absolutely nothing happening to the x. We're not adding, we're not subtracting, so my x value is a 0. Your y value comes here at the very end. Well, there's nothing out there, so my y value is also a 0. So my vertex is at the origin. But this time we need to move up 2 over 1. And then from there I need to move up 6 over 1. Okay, so my axis of symmetry goes right through the vertex, so I need to mirror it across. And there we are. We said it should be more narrow, and if you compare it, look at this guy, he's skinnier. So remember, the bigger your number is out front, the skinnier your parabola is going to be. All right. Okay, so now let's look at our a value. Our a value is 1/2. Look at that number out front. It's 1/2. Okay, so on Friday we figured out that if a is between 0 and 1, like 1/2 is, 0.5, the smaller it is, it's going to make our parabola wider, fatter. Okay, so since a is 1/2, let's see if we can get all of this in here. Zoom out real quick, because I want to look at this guy, right? We always compare to this guy. Okay, well, this is still positive, so I know it's going up and up. The over 1 part never changes. Okay, so since a is 1/2, I need to multiply both of these guys by 1/2. 1 times 1/2 is 1/2. I'm going to put it as 0.5. Then I have to take this 3 and multiply it by 1/2. 3 times 1/2 is 1.5, so that's 1.5. So since my a is 1/2, I just cut both of these numbers in half. So 1/2 and 1.5. All right, my vertex. So I look, for my x, I look at the x. Nothing is being added or subtracted, so my x is 0. For my y, I look at the very end. There's nothing happening out there, so my y is also 0. All right, so my vertex is at 0, 0. This one's going to be a little bit more difficult to graph. Okay, so I want to go up 1/2 over 1. So I'm going to go up half the square over 1. So it's kind of pretty darn close. Okay, then from there I need to go up 1.5 over 1. So here's my half, here's my 1, so it's 1.5 over 1. Okay, this is my axis of symmetry, so I have to mirror it across. All right, I'm going to zoom out a little bit so you can see it compared to the parent function. Okay, so this is when a was larger than 1. Notice it was a skinnier parabola. And this is whenever your a is between 0 and 1, which is a decimal, right, 0.5, and it gets fatter, it gets wider than the original one. Okay. All right, so now we're going to put all those together. Compare it to the parent function, and we're going to look at an equation and say, what are all the changes that are going to happen? All right, so I'm going to pick one thing at a time. First of all, I see this negative that's out front. When a negative out front, that tells me that's going to be opening down. Because my parabola is opening down, I know it was reflected. So I know it was a reflection. Next thing I see is that A is 1/2. It's from this guy, right? Well, when I know A is between 0 and 1, which 1/2 is, It's a decimal, 0.5, right? I know it's going to make it wider. Okay, then I see that we're adding 3 to the x. So I know that's going to either affect it by moving it left or right. Well, we have to remember that x's are liars. So if I'm adding, naturally I would think go forward, but since it's a liar, I know it's actually going to go to the left. 3. And then finally, this guy at the very end is affecting the y, right? The y's don't lie to us. So I know if it's a minus 7, it's going to be moving it down 7. All right. So on B, I know that's a negative, which tells me this guy's going to be going opening down. So we call that a reflection. See that A is 2, right? Well, negative 2, but the negative tells me that it's going to be reflected. It's going down. The 2 is larger than 1, which tells me that it's going to be more narrow. Okay, we are adding to x. So remember, it's the opposite of what we think. So I know it's going to be moving to the left 5. And then this guy, affecting the y, right? Adding 6, which is going to move it up 6. Okay, let's do C. Okay, on C, notice there's no negative out front, so this one's not going to be reflected. This one's going to be opening up. Okay, so there is no reflection. It's opening up. Okay, my x, something is happening to the x. X's are liars, so naturally a minus I would think backwards, but since it's a liar, I know it's really going to go forward. It's to the right. So I know that's moving it to the right, 9. Oh, you know what I forgot, guys? This guy. My A is 3, right? 3 is larger than 1, so remember, the larger that your A value is, the more narrow it is. So I'm going to put narrower out here. Oops. And then finally, I have this minus 2 at the end that's affecting my y. Well, minus 2 is going to move it down 2. I'll do one more with you, and then you can finish the rest on your own, and then we'll probably have a practice. Okay, so on this guy, I see a negative. Negative tells me that it's going to be opening down. Whenever it flips down, that's called a reflection. Okay, my A is a negative 2/3. Yes, the negative tells me it's a reflection, but 2/3 is between 0 and 1. That's smaller, right? So the smaller your A value, the wider, the fatter your parabola will be. All right, next, something is happening to the x. Remember, x's are liars, so it's the opposite of what you think. So when we add to the x, I know it's moving it left. And then finally, this last piece affects the y, up and down, right? And since it's a minus 3, I know it's going to move it down 3. Okay, you try E, F, and G on your own.